Okay, let's go ahead and now look at example 1, 2, 3, and 4, maybe 5 on disjoint and the addition rule. And so we have this rule here, which involves an or situation, where it says, what's the probability of this or that? And here's the situation. If you find the probability of A or B, you add the two probabilities, hence the addition rule, and you minus out any possible intersection of those two events, the probability of those intersections of those two events happening. That's if your events are not disjoint. If they are disjoint, then remember the probability of this equals 0, and then you use this rule here. You don't have to worry about it. This equals 0 if they're disjoint. Let's look at some examples here. First, you want to think about when do you use the addition rule. Again, this will occur when you have a probability problem, right, where it involves two events, something or something else. And so here's the situation. What's the probability of, right here, that someone tests positive or the subject uses drugs? And so looking at this situation, we can see, right, 134 out of 1,000, here's your 134, this is the test positive section, plus the 50 who use drugs. So what's the probability someone tests positive or uses drugs? And then if you look carefully, there's an overlap right in this spot here. There's an intersection, so you subtract that out, the 44 over 1,000. And so you get 140 over 1,000, and that's the answer to this question here, because these events are not disjoint. So you have to subtract out that intersection, which is there 44 who used drugs and tested positive, right? And so that becomes the subtraction right there. Let's look at another situation here. 35% of homeowners, right, hire someone to maintain the yard. 12% hire someone to clean their homes, and 9% will hire someone to maintain both their yard and home. And so what is the probability that selecting a homeowner who hires someone to maintain the yard or clean their home? So that's what we're looking for here. And so we're looking at, there is an intersection, there's an and, because there's a proportion who hire someone for the yard and the home. And so you'll see it's those individual probabilities or proportions minus that intersection. And so you can kind of see this as a Venn diagram also. And then thinking about the complement rule, right? What is the probability of selecting a homeowner who neither hires someone to maintain the yard nor clean their home? And that's going to be the leftover part, everyone else, right? And so that's 1 minus 0.38. Looking at example 3, it's a famous or infamous card problem. What's the probability of randomly selecting or choosing a heart or a queen? And so here are all the possible cards. How many hearts are there? There's 13. Or a queen, there are 4 queens. But then you end up subtracting this one out here because there is one card that is a heart or a queen and a queen. And so that intersection that you end up subtracting out. So the answer is 16 out of 52. And again, you're subtracting that out because it's this intersection. This, right, this is all your hearts. These are all your queens. And so if you look carefully, you'll see there is an intersection right there, that one card. And that goes back to this part here and subtracting that out there. What is the probability of selecting a face card or an ace? Well, these are all the face cards. There are 12 face cards and 4 aces. And so that's where you get a 16 out of 52. Example 4 and 5, employment data at a large company reveals 72% of the workers are married, 40% are college graduates, and half of the college graduates are married. So what is the probability that the person is married or a college graduate? And again, you will see you're going to end up subtracting out a certain amount here. Look carefully. Half of those graduates are married, and that's where the 22 comes from. What if it's neither married nor a college grad? Again, it's the leftover part. That's, again, the complement rule that you have. And then you can see this last one also works out the same way in terms of being able to subtract that out. And again, this is for addition rule when the events are not disjoint, right? If they are disjoint, then you just add the two up. You don't have to worry about the and part.